Welcome. Our next speaker will be talking about missing testing features in Rust. Please, everyone, welcome Daniel Vigovszky.
Thank you. So if we think about missing testing features, or testing in Rust in general, we can say that, well, testing in Rust is quite easy. You can look it up in the documentation. You just write some code, annotate it with this test annotation, and use some assertion macro in it. And that's it. So what is this talk about? Well, before getting to that, let me share a few examples from my past where I had to write some more advanced testing codes. So the first thing that I wanted to share was more than 15 years ago when I was working on a product called Smart Profile. And this was a CAD software, and it involved a complex non-deterministic 3D optimization, and it was implemented in Fortran, C++, and C#. I was writing the C# part. But the whole thing was about doing these calculations, and we had the need to do regression testing, continuously monitoring how our algorithms are producing these results. So we had to compare these custom hierarchical results coming out of this engine, and it had to be carefully executed in parallel and sequential whenever, based on the document types. And it was defined on a dynamic set of documents that was ever growing, and it had to be evaluated after each release. So in this project, I ended up writing a custom test framework in C# for this. And then about 10 years ago, I was working at Prezi, and I was working in the team that was responsible for the collaborative editing feature. And in this team, we also had to test this thing properly, so we created an integration test framework. Initially, it was Haskell, and it was responsible for starting up all kind of dependencies for this system, various services, containers, so on. And it was controlling multiple browser tabs, and in each of these tabs, it was simulating the presentation editor, connecting to our server, and doing parallel edit operations on the documents. So here's an example of this early Haskell integration test framework. And later, actually, we had to migrate the whole thing into Scala because we ran out of Haskell developers. But the key learning for me from this period was that, first of all, the lifecycle management of all these dependencies that the test framework had to start up and destroy was quite hard. And on the other hand, writing these DSLs for describing the test scenarios, it really was worth the effort. And then about 5 years ago, I got involved in several ZIO projects and also started using ZIO primarily for work. So most of my test codes were using ZIO Test. And ZIO Test is a really nice library. It's quite composable. It supports injecting dependencies through ZIO's layer feature. And well, it's not ZIO Test property, but ZIO's structural concurrency support really makes it easy to do complex things in this environment. Here's an example of a test from ZIO AWS, a library that I created back then. You can see that tests are just values. You can define a function. This is a Scala function that returns a sequence of test values. And then you can use these to define multiple test suites and provide different dependencies to them if you want to. And ZIO Test also has this nice test aspect feature where you can modify the behavior of your tests in a composable way. And then about 2 years ago, I started working on Golem. And Golem started as a mix of Scala and Rust code, because we were all Scala developers when we started. But today it's a 100% Rust project. And in this project, it was also very early came up that we need an integration test framework that allows us to define quite complex tests over this environment where you are uploading WebAssembly files to Golem and running them and testing all kinds of behaviors. So some requirements that I had here. So I wanted a similar DSL as I had at Prezi to describe these scenarios. We needed shared dependencies because of some of these dependencies we didn't want to start and destroy for each test. There are thousands of tests. And sometimes these dependencies had to be constructed in async code because of how the underlying Rust libraries were created. And of course, they had to be properly cleaned up. And also, I wanted to keep the ability to run all these things from the IDE, debug them if necessary, run a single test, and so on. And sometimes we want to define a test once and then run it over multiple implementations. For example, you can define how a storage interface is supposed to work and then implement it over various providers and run the same tests over those. And of course, it's a complex project, so some tests are flaky, some tests are timing out, and we have to deal with these. So getting back to the question, what is missing from Rust, I would say all this. and of course, and I could also live with a better assertion library, and I don't like that some of the execution semantics that are only controllable through the command line, for example, whether you want parallel or sequential execution. And the test report feature, for example, JUnit output is also hidden behind the unstable flags. So yeah, there are many relevant traits in the Rust ecosystem. I'm not saying there isn't, but none of these were solving all these requirements in a way that I wanted to. So let me introduce the library that I created for this, called Tester. And the primary goal was to solve all these needs of Golem. And I wanted to solve it without compromises. I wanted it to be as convenient as possible, as similar as possible to using the built-in test framework of Rust. So let's go through some of the features. First of all, it really has the same looks as the built-in test framework. So this is a tester test, very similar to the one that we've seen in the beginning. Of course, it's not 100% true. There are some boilerplate you have to do. In each file where you are using tester, you have to do an import of tester's own test attribute macro. And once in every crate, you have to run this other macro. And you have to turn off the built-in test harness in your cargo file. That's all. Tester also supports async tests without any difference, so you can put the test attribute to the async functions as well, and it will just work. And it has quite good compatibility with the built-in test framework and CLI and IDE features. So for example, in IntelliJ or Rust Rover, you can just click on the test and run it as usual. And if you enable the test view and run multiple tests, it will show you the hierarchy of test runs. And if you just type your usual cargo test commands, it is also working as expected. It also has support for the JUnit output with the same way as the built-in test framework, but no need to use an unstable version of Rust for that. And this is an example of using this feature to show a test report in our GitHub Actions CI. A more interesting feature of Tester is the support for shared dependencies. And if you take a look at this code snippet, you can see that here we have a test function that has a parameter, which is a reference to some kind of implementation of a component repository. It doesn't really matter. And in the other example, you can see that there can be multiple such dependencies of a test. So the question is, what provides how do we get the values for these test dependencies? And the answer is that we have to create functions that are constructing these dependencies and annotate them with test dep. And the only thing we have to do is to return the value of the same type that we were using in the test. And these dependency constructors can also have dependencies, so you can build a hierarchy of these dependencies when you are setting up your test suites. And yeah, and the test constructors can also be async, which is something that I mentioned that was important in Golem. The dependencies are per suite, and the test suite in Tester is just a Rust module. So they are going to be created when before the first test from this test module is starting to execute, and they are going to be dropped after the last test was executed. But you can also inherit these dependencies from a parent module. So in this way, you can create a hierarchy of these things. All right, so just a side note. Before creating testar, I tried to do this thing with a library called ctor, and that is a Rust crate that contains this annotation ctor, and if you annotate a function with it, that is going to run before your main function runs. There were all kinds of problems with this approach. There were problems with creating the async dependencies, because when it was running, there were no Tokyo runtime yet or whatever. There were difficulties creating these in the right order, and even more difficulties with the destruction of these. And testar is also depending on this crate, but it's only depending on it for gathering the test descriptions. So these initializers are running and collecting some information in some static collections, but the dependencies are not created at this point. The dependencies are created for the test as part of the test execution flow, so it doesn't have this problem. And as I said, dependencies are identified by their types. So here you can see the test constructor returns this type, and then the test accepts a reference to this type, and that's how they are matched. But what if we want multiple instances of the same type? Well, you can always just create new types for this, of course. But testar also supports tags for this. So we can have two test constructors returning the same type, but tagged with a different string, and then we can select which one we want to inject to our tests. And this is just the basis for another feature, which is called the dependency matrix in testar. So for example, we can create a couple of test constructors, or creating some kind of blob storage interface implementation, tag them with different tags. We can also create several values of the instances of this blob storage namespace thing and tag them with different tags. And then we can define these test matrix dimensions, where we say the storage dimension has this type, and it consists of these tags. And another dimension consists of the namespace tags. And then in our test, we can use these dimensions to generate a matrix of tests from these dimensions. So for example, in this example, we get 10 different test cases in the end. And these are just regular test cases, so you can run them. You can run all of them by using the original name, because of how cargo test is using the prefix of the fully qualified name of the test to select tests to run. But we can also run only a single one of these, because the tags are used to generate unique names for these generated tests. And what about organizing these tests? As I said, it's by default the same as the built-in test framework. You can create modules, and those are acting as test sets, basically, because of this prefix-based selection of what to run. But there are also test tags, which allows you to group these tests in a different way. So for example, in Golem, we are tagging these worker executor tests by group 1 to 8 or something. And this is very nice to create different groups of tests to be executed. For example, on the CI, we run these groups in parallel, and it doesn't have to reflect the module structure of your test code. And of course, you can tag them per test or per suite. And then you can use this special syntax in cargo test to run a specific tag or a combination of tags. And as I said, I don't like that some things are only configurable through the command line in the built-in test framework. So in testar, everything is controllable with attributes, whether you want to force sequential execution for some tests, or any feature that is supported by the test runner is configurable from code. And about flaky tests, there are 3 relevant attributes: non-flaky, flaky, and timeout. Non-flaky means that I want to be sure that this test is not flaky, so please run it 1,000 times and make sure that it never fails. And flaky means that I know that this test is flaky, but I don't have time to fix it, so please repeat it if it's failing at maximum number of 10 times. And timeout is timeout, of course. These were all inspired by ZIO Test and working pretty well. And the last feature I wanted to show is the dynamic test generators. Everything that I've shown you so far is also possible. I mean, these were so far created by test annotations, but everything is possible at runtime as well. And the generated tests are acting just like the static ones, except that you, of course, cannot click on them in the IDE because there is no source code related to them. But you can create these functions annotated with testgen by making them a dynamic test generator, and then just use this add test macro or its underlying constructs to give a test a name, some properties, which supports everything that is available through test attributes. It also supports the dependency injection part, and then this way you can generate test suites dynamically. All right, so a few details about how this works. So when you are doing cargo test unrelated to testar, what it's doing is it's compiling your code in test mode, which is something you can detect using this conditional CFG test. And then it runs it generates a special main function that runs the test. So what I said, we have to turn off the test harness using harness equals false. That turns off generating this main function, basically. And then this enable macro adds testar's own main function instead. And the test annotation itself is an annotation macro, which generates code that is using CTOR to generate a registration function that adds information about the test to some global list, and then the generated main function can decide how to execute these. And the main function we are injecting here supports exactly the same command line interface as the built-in test harness. That's how everything just works. That's an idea I took from the libtest mimic crate, by the way. And it turned out that just calling the test attribute test, it basically enables the ID integration almost. It works in IntelliJ Rust rover, and in Z it doesn't work in VS Code, unfortunately. The test view panel, for example, in IntelliJ, it depends on this unstable format option JSON from the built-in test framework, and tester can produce the same kind of JSON output, and that's why it's working. And an interesting thing is output capturing. The built-in test runner by default captures the standard output and error, and it remains hidden unless there is an error. So it only shows the output from the tests that were failing. And it's also important for the JSON and JUnit outputs, because there you want to group the output per test in these structures. So how can we do that? And the first problem is, how to do that. And there is a way how the built-in test framework does it. And it's a hard-coded thing in the Rust standard library, and it's not public. And even if it would be public, we are running tests in parallel, so how does it work? Well, this non-public thing is based on thread locals, and that's why it works. But even if it would be public, it wouldn't be good for us, because in testar, the async tests are using the same runtime, a multi-threaded Tokyo runtime, and that because it's important for the shared dependencies. So in this case, a thread local-based solution wouldn't help. It would the outputs would be mixed up completely as the runtime runs on multiple threads. So what can we do? The solution I chose is that I'm spawning a number of child processes, and here the number of child processes is the same as the desired maximum parallelism, which is configurable from the command line. By default, it's the same as the CPU count or something. And capture each child process's output. And the original process is controlling and aggregating these things. And then, of course, in the child processes, everything is running sequentially, so the tests are not mixed up. But then what about the shared dependencies? If we are creating multiple processes, we can no longer have shared dependencies. Well, unfortunately, that's true. We can have shared dependencies and parallel test execution and output capturing, but only can pick 2 at the moment. But tester is trying to do this in a user-friendly way. So if you are not using shared dependencies, it works as the default runner. Parallelism and output capturing is on by default. If you start using shared dependencies, then it turns off parallelism. But if you if you turn off output capturing, then it turns back parallelism and so on. So it's trying to be as friendly as possible. And in the future, well, I'm planning to continue keep it always as compatible as possible with the built-in test runner and with IDEs, because I feel that's very important. I still want to experiment with a custom assertion framework. I know there are many custom assertion libraries in Rust, but I think there is an opportunity here because I'm owning the whole execution code, so I think it enables some possibilities that we can get out a proper value more easily from the tests to the test executor than in the traditional approaches where you can just panic from the tests and then you have to deal with that. And an idea for the problem that I mentioned is that about only being able to pick 2 of the 3 features. There could be per process shared dependencies. If you don't care that much about only having a single instance of something, you could mark that somehow, and that would enable, that would create it once per child process. In some cases, that might work. And finally, this, as I tried to show you, this library solves the problems that I had, which is nice. I wouldn't say it's very elegant. And so because of that, what is the missing testing feature in Rust? I think it is extensibility. You can only do it in a very hacky way right now. And thank you, that was it.
Thank you. I believe we have time for one question.
I lied, I have 2 questions. One, there's actually like a working group for test kind of developer experience under like the cargo team. I don't know if you like reached out to them about any of these like ideas or to kind of share knowledge or anything like that. Were you familiar with that ahead of time?
Yeah, they reached out to me actually, and I was talking with somebody about it already.
Cool. So the second question is, so you mentioned that for test output collection, there's like thread locals involved, and that was an issue that you ran into. But if you use like Tokyo, use the Tokyo test macro, you can also run your test with the multi-threaded runtime. And so it seems like that would run into the same issue. So do you know what they do instead?
Yeah, I'm not sure how they are doing that actually. Yeah, you are right that you can select the multi-threaded runtime there. I think why that works is that with the Tokyo test attribute, it's always creating a separate runtime for each test. So even if it's a multi-threaded runtime, it creates multiple threads for that single particular test. And that's why it's working, I think.
Okay, cool.
Thank you.
Thank you.